Hello everyone, welcome back to my channel. My name is Piyush and this is video number 38 in the series CK 2024. In this particular video, we'll be looking into some common control plane failure scenarios because as a Kubernetes administrator, you are not only responsible for managing your workload, but you are also responsible for making sure that your control plane, your Kubernetes cluster is up and running, it's healthy all the time. And you have to fix the issue, you have to troubleshoot the issue whenever there is a failure. So in this video, we'll be looking into some of those scenarios that are related to control plane components and that are specific to this CK exam. And the comments and like target for this video will be 200 likes and 100 comments in the next 24 hours. It'll be an easy target for you. I'm sure you can do that. And without any further ado, let's start with the video. Alright, so let's start with the first scenario. Suppose you have been given a cluster. This is the same cluster that we were using for a long time. It's a kubeadm cluster, one control plane node, and two worker nodes. And you have been given a task that this is a cluster and it is in broken state currently. So you have to troubleshoot and fix the issue. So we'll start with verifying the status of nodes in this cluster and then we'll go from there. Okay. So first command that you would run is kubectl get nodes. Okay, so I'm getting an error which says the connection to the server, this is the Kube API server address on which it is listening, and on the port 6443, it says the connection was refused. So if you remember the diagram that we looked into, this one over here, Kubernetes architectural diagram, you would know, and this is what we have discussed before as well, you would know that Kube API server is the first point of contact whenever we run any kubectl command or whenever a client is trying to interact with your Kubernetes cluster, right? So the request goes to Kube API server. And if there are any issues with the Kube API server, then you will get some errors, right? So that should be our first starting point of troubleshooting. Plus, okay, we'll go back to the next part as well, but let's first see this. So we see that connection is refused. So now we know that the location of Kube API server will be there in etc Kubernetes manifest directory, which is the default directory of all the static pods, right? Before that, we can do some more checks. Before that, we can have a look at the process if Kube API server itself is running or not. So for that, we could use a docker ps command because Kube API server is nothing but a static pod and a pod has a container. So it should be running as a container process. But we cannot use docker ps command because our cluster is Kubernetes 1.30, and with the latest version of Kubernetes, in fact after 1.24, we are using container D as the default runtime instead of Docker, right? So we don't have Docker installed already on the cluster. And in the exam as well, we won't be getting Docker for sure. So what we can use is we can use CRI-CTL commands. So CRI-CTL is a client for container D. We have already discussed that, right? So first we'll try to look into that CRI-CTL PS. This is the command that we're going to use. In the lab environment, this utility will already be installed. Else, like for your personal hands-on or doing this demo, you can install it, or there'll be a apt-get package for it. Okay, so now it says we have few components that are running. We have etcd master, kube proxy, calico, core dns, and I don't see kube api server. So let's just do a grep on kube api server. So grep api, and only two containers are running, but those are specific to Calico. We don't have API server running. So definitely there is an issue with the API server. So let's go back to the directory of the manifest. So etc Kubernetes manifest. This is the default directory. And over here we have a kube API server YAML. So let me open this sudo vi kube API server. Because this file was created by a root user and root group, we don't have permission to update the file unless we are doing super user login or we are logged in with the root user. So that's why I have to use sudo over here. So if you do sudo vi kube api server, the manifest is there. Okay, but if we have a look, Or let's do one thing. Let's first see if we have any errors in the logs. Okay, so when we did this command, it did not show the API server. But if we update this command to CRI-CTL PS-A, it should show the exited container as well. So that's what we need. And here it says Kube API server, which was exited 7 minutes ago. So if I copy the name or container ID, one and the same thing, and if I do CRI-CTL logs on this container, okay, now this is the error that we are getting. It says container status runtime failed, blah blah blah, container ID not found, an error. So we don't see much over here, right, in the logs. There is a default log directory as well. So if you go to cd var log, okay, and this is in the control plane node. Over here, if you go to containers, right, we have, like, these are the symbolic links, but we should have the log for Kube API server. So let's have a look. Okay, let me do a grep on this as well, but it is showing the Calico server as well. Okay, so we don't see Kube API server logs over here. That means the logs are also deleted when the container exits. Okay, so we'll go back. Okay, I don't see any other directory which should have those details. I have already checked the pods folder as well. So that's okay. We can go back to our etc manifest directory and we can just quickly verify if the content of Kube API server manifest is correct or not. So I'm gonna do sudo vi Kube API server YAML. Okay, and if we have a look at this command, there is an extra R at the end of Kube API server. So the command is incorrect. So if I fix it, and if we have a look at all those things, if everything looks good, if etcd server address is good, if the advertised address is good, this should be your node IP address on which Kube API server is running, and the export port should be 6443, which is over here, secure port, and we have all the keys and everything is there. So rest everything looks good, and I'm gonna just save it. Okay, and let's see the CRI-CTL command. So I'm gonna use Control R for the shortcut, CRI-CTL PS. Okay, it shows the exited, but let me just remove -a and let's have a look. Maybe it takes some time to start the server. Okay, now it says Kube API server is up and running. Okay, and if I do kubectl get nodes now, it is returning the correct results. The kubectl client is now able to interact with the Kube API server and we are getting the results back. So this is how we would fix the issues with the API server. Now there might be some issues where their API server is running, but still this command is throwing error. So in that case, you have to make sure that you are using the kubeconfig file correctly. So the default kubeconfig, as we know, is generated in this folder, $home and .kube. So there'll be a kubeconfig file, which is this. So let's say you have a different kubeconfig file, or if the kubeconfig environment variable is not set correctly. So let me set this export kubeconfig equal to, let's set it to some dummy value /temp config, okay, which does not exist. Now if you run kubectl get nodes, you will get an error something like this. Your connection to the local host 8080 was refused, and did you specify the right port or host, and so on. So in that case, what you will do, you will again check if your API server is up and running or not. So you do CRI-CTL PS grep API. Okay, and it clearly shows that your Kube API server is running. We don't have any issues with that. So there could be issues with either the networking, which we'll cover later, or there could be issues with your kube config. So in that case, what you will do is you could, so if you are not the Kubernetes admin, if you are a user, you can ask your admin to generate a kube config file for you and share it with you, or you can check the default kube config in the, again, in the home directory, right? Or there could be, if you go to cd etc kubernetes, and then there'll be admin.conf, or you can copy this as your default kube config. So let me see, if I do kubectl get nodes, I'm getting the error. Okay, but if I do kubectl get nodes hyphen hyphen kube config, and if we pass this as the kube config admin.conf, it says permission denied. So let me just grant this file permissions, admin.conf sudo chmod, let's say 775 admin.conf. Okay, and now if we do kubectl get nodes and we pass the admin.conf as the kube config, I'm getting the results back. Why? Because now it is taking this as your kube config file, and if we don't pass this, if we don't pass this file and we just run kubectl get nodes, we still will get the failure error. So what you can do in that case, you can copy this admin.conf in your default home directory and .cube folder, the one in which the file was already there. And then you can basically set the kube config environment variable correctly. So if you do export kube config is equal to home dot cube and the file name is config. Okay, and if we run kubectl get nodes, now I'm getting the results back because now I have the correct kube config file which is pointing to this particular location. Right? So with the kube API server, we usually check these things first. Okay, now you must be thinking, I can do this demo because I'm showing you how will you practice this by yourself. So don't worry about that. In the task section, in the task file of this particular day folder, I have placed few shell script that you can just execute on a cluster and it will break your cluster similar to what we are doing now. And then you have to go troubleshoot it and fix the issues. So yes, definitely try to do the hands-on after following this video. Okay, so let me proceed with the next scenario. Okay, so let's try to do something. Let's try to schedule a pod on this particular cluster. So I'm gonna run k kubectl run nginx hyphen hyphen image is equal to nginx. Okay, let's do that. Okay, it says pods created, so let's do a kubectl get pods, and I see it's stuck in the pending state. And if I do a watch on this, it'll be there in the pending state because our cluster is not healthy at the moment. So for that, let's do a kubectl. First of all, let's do a describe on this pod. Okay, describe pod nginx. Okay, and let's see, it does not have any events. Okay, and if we go up and see the node details, the node is none. That means the pod is not assigned to any node till now. Okay, and we don't have any error, but it is still stuck in the pending state. So what could be the reason for that? So we already know that which control plane component is responsible for scheduling the pods on the node. Yes, you are right. It is kube scheduler. So we need to make sure that our kube scheduler is up and healthy. Okay, so if we do k get pods on kube system, it should show all the pods, all the control plane pods that are running, and then kube system. Okay, so we have API server, controller manager, scheduler master, but the scheduler master has an error image pull, and there are no containers that are healthy. Okay, so let's do a log on this, k logs this on kube system namespace, and it says container in pod is waiting to start, trying and failing to pull the image. So there is definitely some issues with pulling the image of kube scheduler. So let's do a describe on this pod, describe pod kube scheduler master hyphen n Kube system. Okay, now let's see the events over here. It says image pullback of error, kubelet pulling image, blah, blah, blah. And it is basically throwing the error that it failed to pull the image. And then it is throwing the image pullback of error. Right. So we see this image name or tag is something is wrong with this, right? So we see at the end it says v1.30, but then it says 200x, which is not something very um something likely to be the correct one. Okay, so let's go to our manifest. So sudo vi kube scheduler. Okay, and over here we see where is the image. Okay, here's the image name, and we need to update it with the correct image name. So now the kube scheduler image for 1.30, I'm not sure what was it. So let me just compare it with the kube API server, or if I do, yeah, sudo vi kube API server YAML, and let's see the image tag that it was using. So 1.30.2. Okay, so I'll just use the same kube scheduler 1.30.2 over here, save it, and then I'll see the status of your pods again. Let's see. Still not came up. Okay, let's do a watch on this. Okay, it says container creating, scheduler master, container running, but still the container is not up. So it might take few more seconds for it to be fully provisioned. So let's wait for that. Let's wait for it to be up and running, and then we'll see the status of pod, whether it is still stuck in the pending state or if it has been scheduled or not. So let's wait for this now. Okay, so now it is up and running. Now if we do get pods, okay, it is running now because now scheduler is able to assign this to a available node. So this is how we will fix the issues with the scheduling. So schedule, scheduling, scheduler, these all are the same terms, and that is the component that we need to look when there is an issue with the pod scheduling. Okay, and this could be an issue like we are not able to assign the pod, but let's say I have created a deployment with two replicas. So if we do get deploy, it has two pods running and both are available. And if we do get pods, both the pods are up and running. So what usually happens when we delete a pod that is backed by a deployment or a replica set? So a new pod will be created, right? That's what we have seen so far. So let's try to delete one pod. Okay, delete pod, and it should automatically create a new pod because it is backed by a deployment. Okay, it says it's deleted. Now if we do get pods again, I still don't see another pod. Okay, yeah, it's been created, right? That's the normal scenario that we have. Okay, so now I have made some changes to the cluster to simulate the failure. So let's try to delete it now. Okay, delete pod. Let's delete any of those pods. And let's see the status. Let's wait for a few seconds and see if it is able to start the pod. Okay, I don't see it happening. If I do get deploy, it says to ready get pods, but over here we don't see, maybe this status has been updated yet, but over here we only see one pod. Okay, and let's do get deploy again. Yeah, so our next pod, so it should have two available pods running all the time because it is backed by a deployment and it has two replicas. So we should have two pods running, right? But it is not happening. So now we know which component is responsible for making sure that all your controllers are working fine. So this is one of the deployment controller or pod controller, right? So who would make sure that all these controllers are working fine? Who will make sure that your server workloads or anything that is supposed to have its own desired state is running fine or not? So that is the job of a controller manager, right? So let's have a look at the pods and see if it is running or not. kube system. And over here we see kube controller manager master is stuck in a crash loop backup state. And that is why it is not able to create another pod, right? So if we go over here, if we copy just this and do a kubectl logs on this -n kube system, let's see if we don't have anything in logs. So let's do a describe on this. It should show us some detail. Describe. No. Describe pod and then the name of the pod. Okay, what it says unable to start the container process, kube controller manager executable file not found in the path. That means there is something wrong with the command of kube controller manager, right? So, and because it was able to successfully pull the image, that's not an issue. It was trying to create the container, but then kubelet throws the error that it's not able to find the command. So let's do a vi on, I'm not really sure the file name. It's kube controller manager. So let's do a sudo vi kube controller manager.yaml and let's see the command. Okay, over here in the command, we see there is an extra E that's been misspelled. If I correct it and save the file, this should come up now. So if I do get pods now, I still don't see it. Okay, let's do a watch on this. Okay, and if there are no other issues, so it should come up. Okay, so it says pending and then container creating state. Now it is able to start the container. Now we just have to wait for container to start responding to the health checks, the liveliness, the readiness props, and then it will be marked as 1 on 1 and it is running. So let's wait for that. Okay, it's up. Now if I do k get pods, how many pods you should see now? Oh, I misspelled it. Okay, get pods. So we have 2 pods running. This pod has just been started because now controller manager is working fine. Now it will make sure that the desired state should be equal to the actual state of the infrastructure. So that's what it did. Okay. All right. So I have made some more changes. So if I do get nodes now, the nodes are healthy. If I do get pods now, pods are also healthy. So let's do one thing. Let's try to scale this deployment and add additional replicas. Okay. So if I do k deploy nginx hyphen replicas, k, actually it should be k scale nginx hyphen replicas. Earlier there were 2 replicas. Let's scale it to 4. Okay, and server does not have a resource type, so we have to specify the resource type as well. Deployment. Okay, it says deployment has been scaled. So if I do k get deploy now, it says 2 out of 4 is ready. And if I do k get pods, okay, only 2 are running, so it's not able to scale the resources. There are some issues again with the controller manager, because again controller manager is responsible for scaling, for adding new pods to the replica, and basically making sure that your desired state is equal to actual state. So now we know that it should be kube controller manager. Okay, so let's do a kubectl logs on kube controller manager and let's see what do we have. Okay, it says command failed, unable to load client CA provider, open etc kubernetes pki ca cert, no such file or directory. So it is throwing the error on this particular file, which is a ca cert. And we know, like what we have seen in the TLS video, is that these certs are loaded with the help of volumes, right? So we actually mount these volumes that has certs and all other manifest and files as the host path on the container. Okay, so let's open this and let's verify if it's mounted correctly or not. Okay, so we go down to the volume section and volume mount section and verify everything related to certs. Okay, so here we have the mount path, which is etc kubernetes pki. This is the correct directory where the cert should be loaded from, and the mount path name is k8 cert. Now these details should match with the volume that we have added in this pod. So if you go down and we come to this section where it says host path, okay, and let's go to etc kubernetes, actually this one, k8 certs, because this is matching with the mount path. Let's verify the path, which is at etc kubernetes pk. So if you notice, instead of pki it is pk over here. That's why it is not able to locate the cert. So if we update this pki and save this file, and let's do log on this, it is getting restarted. That's why the log have not been generated yet. So let's wait for it to be up and running. Okay, it says waiting to start, and we can tail on the logs as well. So kubectl logs and then -f. Okay, now it says starting controller. It is able to load the files. It is able to, yeah, so it says starting ttl controller. Everything looks to be running fine now. So let's clear the screen and let's see the pods. Oh, so we have 4 pods running now. Actually, it is getting started, but yeah, it's running now, right? So we have now seen how to fix those issues as well. Okay, so these are mostly the common issues that will be asked in the exam as part of CK. And you can also check the status of your cluster components with the help of kubectl cluster info command. Okay, it says the Kubernetes control plane is running at this. This is basically your API server. Core DNS is running at this. And that's all the details that we have. And you can dump these details as well by using kubectl cluster info dump. So I'm going to just run it and it will show you all the details. So you can have a look at all those if you want. It is basically, it is describing all those components and it is inspecting the logs and so on. Okay. So and one more thing before we close the session. So you see over here we have the troubleshooting docs. So I will share these links as well in the GitHub repo. So it's basically some scenarios that should be aware of what logs or what files you should be checking whenever there is an issue. So there is this debug cluster, and then there is debugging cluster with CRI/CTL. So CRI/CTL is also important from Kubernetes perspective, from exam perspective, and so on. So make sure you go through all of these. So we have seen that quite a lot of time. So you should be familiar with CRI/CTL now. But please have a look at these two documents as well. And as I have mentioned before, in the GitHub repository of day 38 folder, there'll be tasks. In that task, there'll be certain scripts that you have to execute one by one on your cluster and solve the issues created by those scripts. So do it first, run first scenario and then try to fix the issue. Once that is run, execute the second script and so on. Do not open the script, else you would know what are the issues with the cluster. So I would suggest cloning the repo. I will share the steps, but this is what I would suggest. I would suggest cloning the repo and then just execute the script after providing it execute permission. So once you execute it, it will simulate some failure scenarios, some similar to what I have done over here. And then you should be able to fix the issue by yourself by going through all of these files, logs, directories, and commands. And it will be a good exercise for you or on how to troubleshoot your Kubernetes cluster with respect to control plane. So this is specific to control plane from the perspective of networking and worker nodes. That is also important. So that's what we'll be covering in the next video. So please try to complete the target, the comments and like target of this video as what we have discussed before. And as soon as it is done or in the next 24 hours, I will see you soon with the next video. So till then, keep learning, keep sharing your progress with me on LinkedIn, Twitter, and keep writing blogs, keep completing the task. I will see you then and happy learning. Have a good day. Take care.